ओके, सो लास्ट टाइम हमने कुछ न्यूमेरिकल्स किए थे ऑलरेडी, तो आज के लेक्चर में अगले न्यूमेरिकल्स हम कवर करेंगे. यस, सो दिस इज योर टेक्स्ट बुक. आई थिंक वी हैव डन विथ 15th one, right? And also the 16th one. No, not 16th one, right? Yes, total with the 16th one also. 17th is to be done now. Okay, so let us start. Let's read the question. An unpolarized light with intensity I0 is incident on the two Polaroids. The axis of the first Polaroid makes an angle of 50 degree with vertical, and axis of second Polaroid is complete horizontal. Okay. What is the intensity of light after it has passed through the second Polaroid? Okay. देखो, इसमें हमको मॉलस लॉ यूज करना है, ठीक है, जो कि सपोज ये रे ऑफ लाइट का पाथ है, और इसमें लॉ क्या कहता है कि अगर सपोज यहाँ पे ऑर्डिनरी लाइट जो है, ordinary light which consists of vibrations in all directions, it passes through a single Polaroid, then the intensity will just get reduced to half. First of all, ये हमको समझना है सबसे पहले. और उसके बाद देखो, सबसे पहले जो रे ऑफ लाइट है, तो यहाँ पे जो इसमें से जो फर्स्ट पोलराइड में से जो रे ऑफ लाइट पास होगा, it is going to an ordinary light, means it is going to be unpolarized light, right, which will pass through a Polaroid which is inclined at an angle of 50 degree with vertical. Okay, तो ये सपोज वर्टिकल है, और इस वर्टिकल के साथ ये 50 डिग्री एंगल करने वाला पहला पोलराइड है हमारे पास. ओके, सो दिस रेड कलर से जो हम एक्सप्रेस करेंगे वो सपोज फर्स्ट पोलराइड होगा, ठीक है. अभी इसमें से जो रेज पास होंगे, उनका जो प्लेन ऑफ वाइब्रेशन है वो इस रेड कलर को ही पैरेलल होगा, ये हम समझ सकते हैं आराम से. That means the rays which will pass through this Polaroid, first Polaroid here, will just be parallel to the first Polaroid only. मतलब ये जो 50 डिग्री एंगल पे जो फर्स्ट पोलराइड इंक्लाइंड है वर्टिकल के साथ, तो इसलिए 50 एंगल पे ही इंक्लाइंड वेव्स मतलब वाइब्रेशंस पास हो जाएंगे फर्स्ट पोलराइड में से, ठीक है. अभी ये वाइब्रेशंस जब सेकंड पोलराइड में से पास होंगे, नाउ द सेकंड पोलराइड इज सपोज टू बी हॉरिजॉन्टल, ठीक है, दिया हुआ है वो कि सेकंड पोलराइड इज गोइंग टू बी हॉरिजॉन्टल हियर. दैट मींस द सेकंड पोलराइड कैन बी ड्रॉन हियर इन दिस वे हियर. You can just draw it horizontal like this. Okay, भी ठीक है, वो हॉरिजॉन्टल है, नो डाउट. लेकिन अभी इसमें ये जो पोलराइड है जो हॉरिजॉन्टल है, वो इस डायरेक्शन के साथ कितना एंगल करेगा. अगर हम यहाँ पे इसको अगर कॉपी करके लेके जाएंगे वहां पे, ये देखो, ये सपोज इस डायरेक्शन के साथ अगर उसका एंगल कितना है वो अगर देखेंगे, तो क्योंकि देखो ये ऑलरेडी रेड कलर के जो रेज है वो ऑलरेडी वर्टिकल के साथ 50 डिग्री इतना एंगल कर रहे हैं, बराबर. और ये जो सेकेंड वाला पोलराइड जो है वो हॉरिजॉन्टल है. इसका मतलब अभी देखो ये एंगल हो गया 50 डिग्री. वी कैन जस्ट से दिस एंगल इज गोइंग टू बी 50 डिग्री. ओके, एंड दिस पोलराइड इज हॉरिजॉन्टल, मतलब ये टोटल एंगल जो है वो टोटल एंगल कितना हो गया, 90 डिग्री हो गया. दैट मींस इट शुड बी अ राइट एंगल, सो इट शुड बी राइट एंगल लाइक दिस. So what is the angle between these two? It should be 40 degree. और उसी के ऊपर ये डिपेंड करता है इंटेंसिटी ऑफ लाइट पासिंग थ्रू दिस सेकेंड पोलराइड हियर. तो ये सेकेंड पोलराइड में से जो लाइट पास होगा उसका इंटेंसिटी कितना होगा, तो हम देखेंगे I naught is the intensity of original light. After passing through this first polaroid, intensity will just decrease to half. That means it will become I naught by 2 here. Okay, but since the angle between the direction of ray of light and just wait. ओके, सो ये जो है ये इंटेंसिटी यहाँ पे जो इसमें से जो इंटेंसिटी पास होगा वो इसके लिए इनपुट बन जाएगा. And every time whenever the angle between the incident plane of vibration and polaroid is suppose theta, then we know that according to the Morley's law, the intensity after passing through this becomes actually I naught by 2 gets multiplied by cos square theta actually. So I naught by 2 multiplied with cos square 40 degree. So the final intensity here according to the Morley's law will be I naught square by I naught by 2 into cos square 40 degree in this way. So because see when unpolarized light passes through a polaroid for the first time, then intensity becomes, so we can just say this I dash will actually be equal to I naught by 2. Okay, तो ये सबसे पहली बात हमारे पास हो गई, ये क्वेश्चन नंबर 1 हो गया हमारा. Okay, but when the light, polarized light, okay, passes through polaroid which is at an angle theta with the polarized light. Polarized light का जो plane of vibration है उसके साथ अगर ये polaroid theta इतना एंगल कर रहा है तो उस केस में जो इंटेंसिटी हमको मिलेगा उसको हम बोल सकते हैं I double dash, which will be actually this I dash must be multiplied with cos square theta, where theta is going to be 40 degree, which you have found out here because polarized light का जो plane of vibration है वो इधर इस तरफ है और ये जो दूसरा पोलराइड उसका जो एंगल है वो इस तरह से 40 डिग्री है, इसलिए यहाँ पे थीटा के बदले 40 डिग्री हमको डालना पड़ेगा. तो I double dash, that is the intensity of light coming out from this second polaroid, will actually be I dash into cos square 40 actually, and I dash is already going to be I naught by 2, right? So therefore we can just get that the intensity of light coming out through the second polaroid will actually be I dash, which is going to be I naught by 2 into cos square 40 in this way. Okay, this will be the final answer here in this way. Okay, okay, so let us see the next question now. Eighteenth one here. Okay, just read it carefully. In a bioprism experiment, the fringes are observed in a focal plane of eyepiece at a distance of 1.2 meter from the slits. Okay, the distance between the central bright and 20th bright is 0.4 centimeter. Okay, when a convex lens is placed between the biprism and eyepiece 90 centimeter from the eyepiece, the distance between two virtual magnified images is found to be 0.9 centimeter. Determine the wavelength of light used. Yes. So see here, the suppose there are the two slits here. ये दोनों स्लिट्स है. Okay, and suppose that the eyepiece is placed at this point here. यहाँ पे हमने eyepiece रखा हुआ है, और and the distance between eyepiece and slits is already given. So ये जो distance है already, तो ये दिया हुआ है already. So this distance is already given to be 1.2 meter here. Okay, and the distance between the central bright band and 20th bright band is given to be 0.4 centimeter on the screen here. तो देखो यहाँ पे सपोज सेंट्रल ब्राइट बैंड रहने वाला है. सपोज ये जो स्लिट्स का जो मिड पॉइंट है उसके बिल्कुल सीधा सामने को पता है सेंट्रल ब्राइट बैंड फॉर्म होता है, एंड देयर आर लार्ज नंबर ऑफ ब्राइट बैंड्स formed here, and the total distance between the central bright band and the 20th bright band is actually given to be 0.4 centimeter actually. तो देखो यहाँ पे ये जो डिस्टेंस दिया हुआ है वो 0.4 सेंटीमीटर दिया हुआ है. Yes, so suppose there are 20 bright bands formed here in this distance. Okay, so see here means capital D here is already given to be 1.2 meter. First of all, the second thing is that yes, X means W means bandwidth can be found out just by dividing this distance 0.4 centimeter by 20 actually, because a 0.4 centimeter is the distance of 20th bright band, right? तो 20th bright band का distance कितना होता है सेंटर से, वो होता है 20 times of W here. So इसलिए इस 20 को अगर हम W से मल्टीप्लाई करेंगे तो ये डिस्टेंस 0.4 हमको मिलता है. तो ये 20 को अगर हम डिवाइड कर देंगे इसको तो तब जाके हमको बैंड विड्थ मिलेगा. मतलब एक बैंड का जो विड्थ है तो वो एक्चुअली 0.4 अपॉन 20 के बराबर रहने वाला है, जिसको हम आराम से निकाल सकते हैं यहाँ पे. सो इट विल बी 0.4 अपॉन 20. If you just multiply it by 5, both numerator as well as denominator, so as to make it perfect denominator, multiple of 100 or multiple of 10 here. So यहाँ पे नीचे आ जाएगा 100 और ऊपर बन जाएगा 5 into 0.4, मतलब वो बन जाएगा 2. ओके, तो 2 by 100 मतलब ही वो बन गया 0.02 actually. Yes, so it comes out to be 0.02 centimeter, which may be written as 0.2 meter, or if you millimeter, sorry. If you want to write it in terms of meter, then we can just write it as 0.2 into 10 raised to minus 3 meter. Means it will be 2 into 10 raised to minus 4 meter actually. Okay, so this is going to be the width, bandwidth actually here. Yes, bandwidth तो चलो मिल गया, no doubt. और क्या चाहिए हमको, देखो और आगे यहाँ पे दिया हुआ है when a convex lens is placed between biprism and eyepiece 90 centimeter from eyepiece, then the distance between two virtual magnified images is found to be 0.9 centimeter. Okay, तो यहाँ पे इसमें हमको ये समझना है कि ये सपोज ये दो this is the first and this is the second slit here. Okay, and this is the midpoint, and midpoint के बिल्कुल सीधा सामने यहाँ पे इमेजेस फॉर्म होने वाले हैं. ठीक है, बट यहाँ पे हमने क्या किया कि बीच में लेंस रख दिया है. अब देखो अगर एक ये लेंस अगर हमने यहाँ पे रख दिया इस तरह से, और वो भी कितना 90 सेंटीमीटर पे, देखो ठीक से, और वो भी आईपीस से. हाँ, आईपीस से मतलब जहाँ से हम देखने वाले हैं इधर से, तो यहाँ पे ये डिस्टेंस जो है वो 90 सेंटीमीटर बन गया. तो 90 सेंटीमीटर पे अगर हमने लेंस रख दिया, अभी अगर इस तरफ से वो 90 सेंटीमीटर है तो इसका मतलब इधर से कितना हो गया वो डिस्टेंस, 1.2 मीटर मतलब ये वो 120 सेंटीमीटर हो गया, तो 120 सेंटीमीटर minus 90 सेंटीमीटर becomes 30 सेंटीमीटर actually. So this will be the distance here. So whenever the convex lens is placed between the biprism and eyepiece, 90 centimeter from the eyepiece, the distance between the virtual image magnified images is found to be 0.9. Okay, that means the distance between the images formed here. तो मतलब यहाँ पे जो images form होंगे, यहाँ पे लेंस की वजह से यहाँ पे जो images form होंगी नहीं इन दोनों के, तो उनके बीच में जो distance है यहाँ पे दिया हुआ, is let us call it as d1, and this distance between the two images actually is going to be small d here. So this d1 is actually given here to be 0.9 सेंटीमीटर, तो ये 0.9 सेंटीमीटर दिया हुआ है. ओके, तो अगर ये d1 दिया हुआ है, ये डिस्टेंस भी हमको पता है, ये डिस्टेंस भी पता है, तो इसमें से हम ये डिस्टेंस निकाल सकते हैं कि नहीं, क्योंकि हमको पता है ऑलरेडी इन केस ऑफ द लेंस the image size and object size, image distance and object distance, all of them are just connected by a single formula. That is, we already know that it is image size, or you can say object size upon image size must be equal to the object distance, which is 30 centimeter here, upon 90 centimeter, which is here. Just wait. Okay, sorry. So let us see this d is the object size, and this d1 is going to be actually the image size. Okay, this 30 centimeter is the object distance, and 90 centimeter here is going to be the image distance actually. Okay, so we already have this formula, basic formula, that this object size upon image size is always equal to the object distance upon image distance. So if we use it here, then we just get that d upon d1. d1 is already given to be 0.9 centimeter here. So we can just put it here to 0.9, which is going to be 30 by 90, which can be cancelled by 30, so as to get 1 by 3. So it will be 1 by 3 here. And then we can be able to get this d simply equal to 1/3 of 0.9, which is going to be 0.3 actually. That is also in centimeter, just because this 0.9 was already in centimeter. Okay, so 0.3 centimeter ये हमको मिल गया d का value. Once we get this, we can just be able to find out the wavelength now. That is to be found out here. Wavelength of light used. तो wavelength के लिए फॉर्मूला क्या है हमारे पास? देखो, w के लिए फॉर्मूला हमारे पास ऑलरेडी है लैम्बडा इंटू कैपिटल D अपॉन स्मॉल d. ये w के लिए फॉर्मूला है. इसको ही हम अगर सपोज उल्टा करते हैं, लैम्बडा के लिए अगर अरेंज करते हैं, तो हमको मिलेगा लैम्बडा इज इक्वल टू कैपिटल W इंटू स्मॉल d upon capital D, right? And then we can just put all the values here in this formula so as to get the final answer. तो जबकि यही सभी हमको पता है ऑलरेडी. देखो W तो ऑलरेडी हमने यहाँ पे निकाल के रखा है, तो let us put it that here. W के बदले हम डाल देंगे 2 into 10 raised to minus 4. Okay. Then small d is obtained here just now. That is 0.3 centimeter, which has to be converted into meter. Don't forget that. So it will be 0.3 into 10 raised to minus 2 meter, and that is to be divided by this capital D, which is going to be 1.2 meter here. That is 1.2 kept as it is here. So if we just work this out, then lambda can be obtained easily. First of all, we'll just collect all the 10 powers, power of 10. तो ये पावर ऑफ 10 अगर कंसिडर करेंगे, तो यहाँ पे 10 raised to minus 4 और ये 10 raised to minus 2 मिलके बन जाएगा 10 raised to minus 6, और ये 2 into 0.3 मल्टीप्लाई होके बन जाएगा 0.6, right? So this is going to be 0.6 there in the numerator, and here in the denominator it will be 1.2, and this number must be multiplied by 10 raised to minus 6, and that is going to be in meter actually. So 0.6 is just half of 1.2, so you can just cancel it out and get it at 1 by 2. 1 by 2 can be written as 0.5, and hence we can just write it as 0.5 into 10 raised to minus 6 meter, which can also be written in angstrom if you want. इसको हमको angstrom में अगर लिखना है तो 0.5 into 10 raised to minus 6 can be written as, sorry, so lambda, that is the wavelength, will be actually इसको 10 raised to plus 4 or minus 4 से multiply करना जरूरी होगा. So if you just multiply this 0.5 by 10 raised to plus 4 and 10 raised to minus 4 also, and 10 raised to minus 6 is kept as it is here, then we can just be able to get this finally as lambda is equal to, अच्छा सबसे पहले ये जो 10 raised to minus 4 into 10 raised to minus 6 है वो 10 raised to minus 10 बन जाएगा, और 0.5 into 10 raised to 4 जो है वो 5000 बन जाएगा. So finally we can just get that 5000 and into 10 raised to minus 10 meter, which is nothing but 5000 angstrom. Okay, so this will be 5000 angstrom as the final answer, which is already there in this answer here. Okay, let us see the next question now. Yes, 19th one. In case of a Fraunhofer diffraction by narrow slit, a screen is placed at a distance of 2 meters from the lens to obtain the diffraction pattern if the slit width is 0.2 millimeter. And the first minimum is okay, the first minimum is 5 millimeter on either side of the central maximum. Okay, find the wavelength of the light once again. So see here, in case of the diffraction pattern, as we already seen, the central maxima, it's suppose this point here, यहाँ पे अगर central maxima form होता है तो first minima जो होता है, first minima, तो वो हमेशा कितने डिस्टेंस पे फॉर्म होता है वो हमको पता है ऑलरेडी, उसको ही हम W बोलते हैं, और वो W जो है वो दिया जाता है इस फॉर्मूला से, लैम्बडा इनटू कैपिटल D अपॉन स्मॉल d here. So this is the distance of first minima from the central maxima, and it is distance here. And ये जो डिफ्रैक्शन पैटर्न जो प्रोड्यूस हुआ है तो वो जिस स्लिट की वजह से हुआ है तो उसका जो विड्थ है उसको हम बोलते हैं स्मॉल d. ओके, सो इसलिए यहाँ पे जो दिया हुआ है वो यहाँ पे नोट डाउन करेंगे फटाफट. देखो, Fraunhofer diffraction by narrow slit, the screen is placed at a distance of 2 meters. That means capital D is actually given to be 2 meters here. From a lens to obtain the diffraction pattern. If slit width is given to be 0.2 millimeter. So slit width मतलब क्या हुआ? यहाँ पे ये small d दिया हुआ है 0.2 millimeter के बराबर. And the first minimum is 5 millimeter on either side. Okay. That means the distance of first minima is given to be 5 millimeter. That means in short, W is given here. So W is going to be 5 millimeter. And using all these three values, we have to find out the value of lambda. So we have the ready-made formula for that. W is equal to lambda into capital D, that is to be divided by small d, right? So we can just find out lambda to be simply equal to W into small d upon capital D. So that we can get it as W, which is 5 millimeter. Don't forget to convert it into meter. So it will be 10 raised to minus 3. Okay. Then small d, which is 0.2 millimeter, which can be written as 2 into 10 raised to, actually write it as it is. So 0.2 into 10 raised to minus 3 millimeter. to be divided by D, capital D, which is 2 meter. So this is 2 meter here. So if we just try to find out once again, it will be actually 5 into 0.2, which becomes 1, and 10 raised to minus 3 into 10 raised to minus 3 becomes 10 raised to minus 6. So here it is 10 raised to minus 6 and 1 by 2 kept as it is, which is once again going to be 0.5 into 10 raised to minus 6 meter, which can also be written as 5000 angstrom. Okay, so this will be the correct answer, which is already there. Move to the next question. The intensity of light coming from one of the slits in Young's double slit experiment is twice the intensity of light coming from other. Okay, the intensity of light coming from one slit is in Young's experiment is twice the intensity of light coming from the other slit. What will be the approximate ratio of intensities of bright and dark fringes in the resulting interference pattern? Okay, तो देखो यहाँ पे ये एक सिंपल सा प्रॉब्लम है जिसमें एक स्लिट में से निकलने वाला जो रे ऑफ लाइट है उसका इंटेंसिटी और दूसरे स्लिट में से जो निकलने वाला लाइट है उसका इंटेंसिटी का रेशियो हमको दिया हुआ है. मतलब ये दिया हुआ है if suppose this first ray of light starts with the intensity I1 and the second ray of light starts with the intensity I2 here, then it is already given that I2 is equal to 2 times of I1. Okay, ये सबसे पहली बात दी हुई है. और what will be the approximate ratio of intensities of bright and dark fringes in the resulting interference pattern? तो पैटर्न के अंदर ब्राइट फ्रिंज का इंटेंसिटी जो है वो मैक्सिमम होता है, जिसको हम आई मैक्स बोलते हैं, जो कि एक्चुअली एम्पलीट्यूड्स के सम के स्क्वायर के ऊपर डिपेंड करता है, बराबर. और डार्क पॉइंट पे जो इंटेंसिटी है वो मिनिमम हुआ करता है, जो कि एक्चुअली एम्पलीट्यूड स्क्वायर के डिफरेंस के स्क्वायर के ऊपर डिपेंड करता है, राइट. और इफ यू जस्ट टेक द रेशियो ऑफ दिस हियर, सो वी कैन गेट दैट आई मैक्स टू आई मीन हियर will actually be equal to the square of a1 plus a2 upon a1 minus a2 here. But the problem here is that we don't know a1 and a2 here. We just know that is I2 and I1, and it is given that I2 is equal to 2 times of I1 simply, which can also be written as I2. अब देखो इसमें एक बात क्या कि I1 upon I2 is actually going to be 1 by 2 here, but I1, don't forget that I1 is proportional to A1 square, and at the same time I2 is proportional to A2 square here. So if you just take the ratio of these two here, then we can get that I1 upon I2 is going to be I1 upon I2 is going to be equal to A1 upon A2 का whole square, correct है? But I1 upon I2 is already 1 by 2 given here, so we can just use that 1 by 2 is going to be the ratio of A1 upon A2 का whole square here. Okay, so A1 upon A2 का whole square का ratio 1 upon 2 है, तो इसका मतलब A1 upon A2 का simply ratio कितना होगा? So simply it will be 1 by root 2 actually. Yes, 1 by root 2. That means A2 is going to be root 2 times of A1. So you can use that A2 is going to be root 2 times of A1. And if we use this here in this equation, ये equation के अंदर अगर हम use करेंगे इसको, तो देखो next step में क्या मिलेगा हमको? So you can just get it in the next step, that is I max to I min ratio will be actually यहाँ पे A2 के बदले हमको डालना है root 2 A1, so that we can just get this as A1 plus root 2 A1, and here it is again A1 as it is minus a2 के बदले √2 a1 फिर से. If you just take this a1 common and just cancel it out, a1 यहाँ पे बाहर आएगा तो अंदर में बचेगा 1 + √2 का होल स्क्वायर, और यहाँ पे भी a1 कॉमन आएगा और बचेगा 1 - √2 and the whole square kept as it is. This a1 will get cancelled, and if we just square on both numerator as well as denominator, तो अगर ये दोनों का square अगर हम expand करेंगे according to the formula which we already have, that a plus b the whole square, or we can just first of all we can just rationalize the inside term and then we can just square it afterwards. It's okay. Okay, if we just square both the numerator as well as denominator here, then we can get this 1 plus 2√2 plus √2 का whole square, मतलब 2 here, and in the denominator also it will be 1 minus 2√2 plus 2 here, which will become actually 1 plus 2 is 3, so 3 plus 2√2 upon 3 minus 2√2. Okay, which on rationalizing gives, तो यहाँ पे इसको हमको rationalize करना है, जिसमें से हमको मिलेगा यहाँ पे ये 3 minus 2√2 नहीं 3 plus 2√2 से हमको मल्टीप्लाई करना पड़ेगा इसको, और यहाँ पे भी 3 plus 2√2 से मल्टीप्लाई करना पड़ेगा, so that we can just get this in the next step. So here it will be 3 का square, मतलब वो बन गया 9 plus 2√2 का डबल, मतलब वो बन गया 4√2, और 2√2 का स्क्वायर मतलब बन गया 8, और डिनोमिनेटर में a plus b into a minus b becomes a square minus b square. That means it becomes 9 minus 8, which actually becomes 9 plus 8 मतलब 17 plus 4√2 upon 1, which actually happens to be, but nowhere it's coming close to 34 actually. Method is correct. There may be some mistake in the question itself. So 17 plus 4√2, how much it comes out to be? √2 का वैल्यू अगर 1.4 भी डाल दो तो उसका 4 टाइम्स कितना बनता है? 4 के आसपास, 21 के आसपास आ जाएगा. Just forget about it. Method याद रखो ठीक से. There may be some mistake in the question, which will I just check it and just return back next time. तो कल के लेक्चर में हम ये डिटेल में फिर से एक बार देखेंगे कि क्या इसमें मिस्टेक है. फिलहाल नेक्स्ट क्वेश्चन हम सॉल्व करेंगे. Yes, it is the 21st question here. A parallel beam of light, green light of wavelength 546 nanometer passes through the slit of width 0.4 millimeter. The intensity pattern of transmitted light is seen on the screen, which is 40 centimeter away. Okay. What is the distance between two first order minima? Okay, so first minima के बीच में जो distance है वो हमको ढूंढ के निकालना है. तो मतलब देखो, ये सपोज ये हमारा स्क्रीन है, सॉरी ये स्लिट है, और समझो कि यहाँ पे स्क्रीन फॉर्म हुआ है, ये स्क्रीन है. तो इस बिल्कुल मिनिमा इस स्लिट के बिल्कुल सीधा सामने हमको पता है सेंट्रल मैक्सिमा फॉर्म होता है, बराबर, और उसके आजू बाजू में मिनिमास फॉर्म होते हैं. ये सपोज सेंट्रल मैक्सिमा, ये मिनिमा. So we want to find out the distance between the first minima on either side. ये जो टोटल डिस्टेंस है हमको ढूंढ के निकालना है. एक्चुअली ये जो है ये डिस्टेंस W हुआ करता है, और ये नीचे वाला जो डिस्टेंस है वो भी W हुआ करता है. तो ये टोटल W प्लस W अगर हम ऐड करेंगे तो ये टोटल हमको मिलेगा 2W. वो हमको ढूंढ के निकालना है. So the required distance will be actually 2 times of W, where W itself is going to be lambda into capital D upon small d. Okay, and just see that everything is given here. The wavelength of light used is 546 nanometer, which can be replaced here. So 2 times of 546 nano matlab 10 raised to minus 9 here, and capital D is going to be 40 centimeter. ये देखो यहाँ पे स्क्रीन जो है वो 40 सेंटीमीटर अवे बोला है, तो वो 0.4 मीटर उसका डिस्टेंस हो गया, और डिवाइडेड बाय स्मॉल d, which is the distance or slit width, which is 0.4 millimeter. So it will be 0.4 into 10 raised to minus 3 here. So that this 0.4 just get cancelled from numerator and denominator, and we will have to just double this 546 here. 546 को अगर डबल करेंगे तो कितना मिलेगा हमको? Almost it will be 2 6 are 12, 1 carry 9. Here it is 10. Okay, so 1092, and that is to be multiplied with 10 raised to minus 6 here, which can be written as 1.092 into 10 raised to minus 3 meter, and which can be approximately written as 1.092 millimeter, and 1.092 approximately can be written as 1.1. So we can just get it as 1.1 millimeter here, which is already there in this option here. Okay. Okay, how many questions are left? 4 to 5 questions are left. We can just do it in the next lecture tomorrow. Okay. So let us stop this lecture here. If you have any doubt, you can just put it in the chat box. Last मतलब इसके पहले का ना? This one is here. $21 क्वेश्चन तो ये है. Okay. ठीक है, चलो, so let us stop.